Hi dear students, welcome to Wisdom 24 channel after a long time. Today we are going to see the new topic of digital world, of digital electronics. And digital electronics we are going to see new topic. Okay, I will give introduction today regarding that. So under digital world, that means in digital logic, the inputs and outputs of a function are in the form of a binary numbers. In digital world, the inputs and outputs of a function are in a form of binary numbers. That means in digital electronics, the inputs or either the output of any function, it should be in the binary form. That is, either it will be in a 0 or 1. So they are all the Boolean values. That is, the values are either 0 or 1. Therefore, digital logic is also called as a Boolean logic. Boolean logic is nothing but a digital logic where it is representing only in the form of 0 or 1. That is the very important key point we should understand in the digital electronics. Either the communication, whether it may be input or output, definitely the function it is in the form of either two values, that is 0 or 1. So it is called as a Boolean logic. Okay, the next point we have to consider is these input and output can be termed as Boolean variables. The logic is called Boolean logic, and these variables 0s and 1 is called as a Boolean variables. That we have to importantly notify that. Next, the output Boolean variable of a digital signal can be expressed in terms of input Boolean variables, which forms a Boolean expression. The output Boolean variable of a digital signal can be expressed in terms of input Boolean variables, which forms the Boolean expression. See, here three terms we are crossed. One is Boolean values, next Boolean logic, next Boolean variables, and the next one is Boolean expression, where with the help of Boolean variables we are doing any form that is called as a Boolean expression. That is, the Boolean expression is nothing but it is a combination of zeros and ones. Okay, so these are all the basics of digital electronics or digital logic. Okay, now how we are going to representing the Boolean expression? That basically it is divided into two ways. Representing of Boolean expression can be primarily done in two ways. They are SOP form and POS form. That is, sum of products form. Second one is product of sum form. See how the beauty of this types are in the name itself we will understand the meaning. Sum of products form. That means first we have to do the product of the product expressions, we should sum it. That is sum of products, and another one is product of sum. For the sum terms we are doing the product. Here for the product terms we are doing the sum. So finally we are getting these two forms. Okay, now we are going to see each and everything in a proper way, these two ways. Before that, one thing I have to give a note. If the number of input variables is n, if the number of input variables is n, that means whatever may be the input variable, whatever may be the value, say that is a 2, 3, 4, 8, whatever it may be, let me take that input variable common as n. If the number of input variable is n, then the total number of combinations in Boolean algebra is 2 to the power of n. Whatever may be the input value, that the total number of combinations, while we are giving input, the combination should be in a Boolean expression, the combination should be happen in that particular process, no? So that the expression, it will be number of combinations we will get as a 2 to the power of n. That is, if the input variable is let value is 0, see here I hope you understood 2 to the power of, for example, here if it is 3, n is 3, 2 to the power of 3, that is 8 combination you will get. If here n is 4, 2 to the power of 4, 16 combination you will get. That is, based on the value of the input variable, your number of combination will be exactly 2 to the power of that n. So if 0 means the logic is 0, it should be represented as the complement of a. Okay, a is low. In Boolean logic, I told you AND operation and OR operation, that is sum operation and product operation. AND is represented as DAT. That is, if you want to multiply the two variables, we have to use the AND logic. That is, A and B is written as A dot B. OR logic is represented by addition. That is, A or B is written as A plus B. That is a basic thing we have to understand in the digital electronics. For example, considering number of input variables, see, as I told you before, see, if input variable is 3, that is A, B and C, or either it may be any variable X, Y, Z, M and P, whatever it may be. Just here we are defining the names, we ourselves giving a names for the variables. Okay, so the total number of combinations are 2 to the power of 3, that is 3 variables. No, 2 to the power of 3 is equal to 8. So 8 combinations we are having for the operation for these 3 input variables. Okay, I hope you understood. Now we are going to see that this 2 ways of representing the Boolean variables, no, that we are going to see one by one. Sum of products. Okay, what is first term is sum of products, first type. So sum of products is nothing but it is one of the ways of writing a Boolean expression. It is one of the way of writing a Boolean expression. I told we have 2 ways. One is sum of product and another one is product of sum. Here what is the one of the way of writing a Boolean expression? As the name suggests, it is formed by adding the product terms. See, sum of products, we are adding the product terms. These product terms are also called as a min terms. Sum of product is nothing but min terms. Please remember this. There are 2 terms, min terms and max terms we are defining. Min terms is particular for the sum of product terms. Min terms are represented with M. They are the product of Boolean variables either in a normal form or a complemented form. Okay, min term generally we are representing with small m. Okay, 1 minute. Okay. Okay, generally we are representing min term in the form of small letter. 1 minute. Yeah, min terms are represented with small m. They are the product and operation of the Boolean variables either in normal form or complemented form. For example, A, B, C is a normal form. A bar, B bar, C bar. These are all the complemented form. Either the combination of these 6 forms will give you the min term representation. Therefore, SOP is a sum of min terms and is represented in the form of, m of, that is small m of. Please remember there are 2 ways of representing the alphabets m. Here we are representing in small letter. We are representing in small letter means that is definitely it is min term. Definitely it is min term. Yeah, small m of 0, 3. Here f is the sum of min terms and min term 0 and min term 3. For example, these 2 terms. For example, A0, B0, C0 means min term is ABC. A1, B0, C1 means combination. Here we are speaking about the combination. So min term is A dot C. 1 we are representing in the form of A itself, but 0, B is 0, so we are representing in the form of B bar or B dash. C is 1, C as it is. Here also A0, B0, 0, 0, A dash, B dash, C dash. Are you observing this? Dash is there. See, for example, if I am taking here dash, okay, here dash means complement. A dash, B dash, C dash means complement. If I am removing the complement means here the meaning will change. That is, A should be 1, B should be 1 and C should be 1. If all the things should be 1, then there is no complement term here. This way we have to understand the logic and we have to proceed. Okay, consider a function A whose truth table is as follows. As I told you, for a sum of min terms, see here, if A, B, C, 0, 0, 0, that is x is 0 only, because for this expression we are dealing. Okay, for this expression we are dealing. Yes, so 0, 3, that means 0, 3 means what do you mean by that? Yeah, see, 0, see, this is 0 term, 1 term, 2 term, 3 term, 4, 5, 6, 7. So these are all the 7. That means from 0 to 7, 8 combination we said out. Here we told that is sum of product in terms of 0, 3 only, right? 0, 3. Okay, so for in the place of 0 we are putting 1, and in the place of 3 we are putting 1. That is 0, 1, 2, 3. Remaining everything is 0. See here, 1, 1, 1. 1, 1, 1, 0. So here you have to write the expression A bar, A dash, B dash, C dash, that is equal to 0. That is a sum of product terms. 0, 0, 1, that is 1. So this is a combination. This is a general table for your Understandable. The function x can be written in the SOP form by adding all the min terms when x is high. While writing SOP, the following terms is see here in the place of 1. This is different. Okay, this is simply I told you to, I expressed here to know the basics of SOP form. But here, see, for this expression, if you want to write, see, for this expressions, for this truth table, if you want to write an expression, please observe here. Here it is 0 term. See, I will write here. Here it is 0 term. Yes. Okay, here it is 0 term. This is first term, second term, third term, fourth term, fifth term, sixth term, seventh term. Yes. So here, where and all 1 highlighted, you just note here. Here 1 is for 1, again for 2, 0, 1, 2, 3. 1, 3, 4, 5, 6. So 1, 3, 6. For this terms only you are having highlighted. That means you are having a high signal as an output. So here, say, note here. Can you observe this? 1, 3, 6. See, according to this truth table, 1, 3, 6, the highlighted or there is active high output is in the place of 1, 3, 6. So here 1, 3, 6. That is the min terms of 1, 3, 6. Yeah, min term of 136. That is, you come here. Now you compare here for 1. For 1, what is the combination? A bar, B bar, C. That is 0, 0, 1. See, please observe here. A bar, B bar, C. Yes. For the min term 3. For the min term 3, that is here. A bar, B, C. That is 0, 1, 1. A bar, B, C. Come here. See, A bar, B, C. Next, sixth term, that is A, B, C bar. A, B, C bar. See, everything here you see, observe here, dot, dot I give. That means product. That means product of the particular term. So, this add symbol will show you sum. That is sum of the product of the terms is called as a SOP. That is sum of products. In this way, we are representing the Boolean expression. If we have any truth table, any combination of truth table, any number of input variable, according to the truth table, we are forming a Boolean expression in SOP form in this manner. Okay, I hope you understood clearly. If you have any doubt, please ask me in the comment section. I will get back to you. Product of sums. Okay, product of sum. This is the another way of expression, Boolean expression. As the name suggests, it is formed by multiplying the sum terms. As the name suggests, it is formed by multiplying the sum terms. These sum terms are also called as a max terms. Max terms are represented with M. They are the sum of Boolean variables, either in a normal form or a complemented form. As I told you before, normal form is A, B, C. Complemented form is A dash, B dash, C dash, or A bar, B bar, C bar we will express. Therefore, PO is the product of max terms and it is represented by capital M of 1, 2. That is any term. Here we are speaking about, this is nothing but a combinations. Here F is a product of max term and max term. That is, for example, you see here we are putting a symbol that is OR operation, but here we are putting a symbol that is AND operation. And you have to remember the basic difference between the product of sum and the sum of product. So max term is A plus B plus C. See here it is A, B, C. See, and one more, the major difference you have to note here. Here we are using for zeros and all, we are using bar, A bar, B bar, but here for 0 we are putting the term as it is, and for a highlighted symbol, that is for 1, we are putting a bar. There is a major difference you have to note in both. See here, so A plus B bar plus C. Here A bar plus B bar plus C bar. That is where and all you have an active high signal, there you are representing here in the complemented form. That is a max term uniqueness. Okay, consider a function whose truth table is as follows. Here you see A, B, C, X. Here also the same combination, 0, 1, 6 highlighted, but here you saw comments here 0, 2, 4, 5, 6, 7. It's a normal table. You just represent it. Here is a normal truth table for 0. For 0, that is for this term, A bar, B bar. As I already told you, here the active low signal will be considered as a normal form, and active high signal is complemented as a normal complemented form, and active low signal is considered as a normal form. So here it is 0 is represented as A, B, C. That is for 0 you are putting A plus B plus C, and for 2, for this representation for 2, 0, 1, 2, for this 2 A plus B bar plus C. Yes, A plus B bar plus B. So for 4, come here. A, see this is 0, 1, 2, 3, 4, right? So for 4, A bar plus B plus C. See for 4th term, A bar plus B plus C. Next for 5th term, A plus B bar plus C. A plus B bar plus C. So for 5th term, A bar plus B plus C. See here, A bar plus B plus C. And for 7th term, there is a last term. All are high, but in product of sum term, for active high signal as an input, we are considering as a complemented form, right? So A bar plus B bar plus C bar. Yeah. In this way, we are representing the product of sum in digital world. Okay. I hope you understood the basic things here. So under digital world, the basic thing we came across what is digital value, what is Boolean value, what is Boolean logic, what is Boolean variable, what is Boolean expressions, and what are the types of representing the Boolean expression, SOP form and POS form, and clearly came across what is SOP form and how we have to represent it, and which variable we have to represent, which alphabet we have to represent, and which number we have to take in a complemented form and which number we have to take a normal form in both the terms. The basic difference between that two we are going to see in the tabular column. It is a replica. Yeah, we will see that. Difference between SOP and POS form. A way of representing Boolean expressions, the sum of product terms is called SOP. A way of representing the Boolean expressions, the product of sum terms. See, this name itself representing the difference between that. Next, SOP uses min terms. Min term is a product of Boolean variables either in a normal form or complementary form. But POS uses max term. Max term is a sum of a Boolean variable. Say, min term is a product of a Boolean variables. Max term is a sum of a Boolean variables either in a normal form or a complemented form. That we have to understand. Next, it is sum of min terms. See, first min term is nothing but product of Boolean variables. Simply we have to say min term is nothing but a product of Boolean variables, and max term is nothing but a sum of a Boolean variables. Here the next step we are entering. So it's here in under SOP form, the P represents the second point and S represents the third point. It is a sum of min terms. Min term is nothing but a product terms. Sum of that product terms, that is the sum of min terms, are represented as small m. Sum of min terms are represented as sum of min terms are represented as small m. It is a say for in under POS, it is a product of max term, that is max terms are represented as capital M. SOP is formed by considering all the min terms whose output is high. Here is the very important point I told you. In SOP, all the min terms whose output is high is considered. SOP is formed by considering all the min terms whose output is high, but POS is formed by considering all the max terms whose output is low. Here I told the basic difference here, right? Yeah. Next, the next point is SOP is formed by considering all the min terms whose output is high. Already we spoke that. Fifth point, while writing min terms for SOP, input with value 1 is considered as a variable itself and input with value 0 is considered as a complement of the input. Yeah. While writing a max terms, input with value 1 is considered as the complement and input with value 0 is considered as the variable itself. This, all the 5 points we discussed very clearly. I hope so. Apart from this, if you have any doubt regarding SOP and POS form, and if you want to solve a very complicated problems, if you need my help, definitely you can chat with me in a comment box. I will get back to you. Thank you, students. We will meet you in another video.